First type are what I call mixture problems. All right, I want you to mix this with this to come up with this type of solution, and how much of the originals do I need? So quickly go through number one here with me. I'm going to mix 10% of sodium iodine with 60%. And when I mix it together, I need 30% solution, and there's got to be 50 milliliters with it. So how much of each do I need? I'm going to make this real easy. I'm going to draw this. All right, I'm going to draw the mixture. So here we go. The drawing looks like this. I got bucket number one. What type of solution do I need first? Read through the problem. What type of solution do I need first to mix? I know they're all sodium iodines, but what type? 10%. So in bucket number one, take a look. I'm going to put the 10% solution. Do I know how much I have? No, that's the question. I need to know how much of that solution do I need. So I'm just going to put X. So that shows you in bucket number one, you got the 10% solution. All right, I need to mix that, add it, mix it with, here's your second bucket. What's the other type of solution I'm putting with it? 60%. Do I know how much I have of that? I'm trying to find it. Now, is it necessarily the same as the 10? No. So I'm not going to put X. I'm going to put Y, because it's not necessarily the same amount. All right, mix them together. You got the final bucket, which has what in it? Okay, 30% solution. But here, I don't need to introduce a third variable. I already know how much I need. How much? There you go. So under here now, I'm not going to put a third variable. I'm going to put 50 because I need 50. Everyone all right with my diagrams? Showing you literally what I'm mixing together and what I need. All right, what are my two equations going to be? Look in your buckets. Your two equations that you're going to solve together are already in the bucket. Ready? First one. How much I need? X plus Y, total amount of 50. There's equation number one. Second equation, percents go with them now. Okay, now I apply the percents to all of them. But I think we've done a lot of these type of problems when we did banking. Like remember you have a 4% interest rate. Did you automatically plug 4 in? No, you didn't. What'd you do with the 4 before you plugged it in? You did what, Dylan? Move the decimal over 2 spots. It's the same thing here. I'm not going to put 10x. I'm going to put 0.10x. 10% solution plus 60%, 0.60y. Watch now what happens on the other side. Ready? Okay, 0.30. What am I going to multiply it by?
X, what?
No. Follow my pattern. 0.1x plus 0.6y equals 0.3 times. How much do I have? 50. Yeah. And I see some of you go if you want to take care of that right now, go ahead. 0.3 times 50. Just know where that number came from. And what's that number? 15, I think it was? No? 15? And just remember, hey, that was 0.30 times 50, where I got that from. All right, I'm nervous here now. Not in your math ability, but I've seen some of your writing. I've had to correct it all year long, which I don't mind because that's what I'm supposed to do. You have decimals now. Watch your writing. Watch how neat you end up being here, all right? Watch it. You have decimals. Okay, we have done 2 days of this. Eliminate a variable. Okay, 2 equations, 2 variables, eliminate one of them now. How do we eliminate one of them? Multiply one of them by a number, probably this top one. What could I multiply the top one by to eliminate either X or Y up here? You have 2 options. Let's go 5. What do you want to multiply by?
-0.1.
Fine. Or you could do -0.6. to eliminate the y. So we'll multiply this first equation by negative 0.10. Darn it! Take your time. You have decimals right now. All right? Easy mistakes can happen when you're working with the decimals. Distribute, distribute, distribute. Negative 0.10x minus 0.10y equals, distribute it on the other side. Take your time. You have decimals. Make sure they get put in properly in the calculator. Negative 5, I hope. Everyone's getting out negative 5. All right, take your time again. X's cancel. That's what we wanted. 0.6 minus 0.1. 0.5y, 0.50y equals 10. Keep going. And then I'll ask somebody how much of the solution you had. So it looks like this is the 60% solution here. So how much of that 60% solution did you have when you're ready? 12? 20 milliliters. Good deal. You don't have to put the label, but. And now, just like we have done the last 2 days, how do you find my other variable? Go back to one of the two equations. Probably not the decimal one, right? Probably the x plus y equals 50. Plug it in. And when you're ready, let me know how much of the 10% solution you had. Mixture problems. When you're ready, how much of that did I have? 2? 30 milliliters. Got it. Everyone's good? All right, so there's percents mixing with it. I could also do another mixture that looks a little different, but I'm still going to draw out the diagram. So now we're doing tea. One type of tea is $6 a pound, the other's $8 a pound. I mix them together. So I get a tea that's $7.50 a pound. Ready? There you go. Bucket number 1. What's in bucket number 1? What type of tea? $6 tea. How much do I have? Don't know. I'm going to call it X. So I got $6 instead of percents. Now I'm working with money. Mix it with. What am I mixing the $6 tea with? $8 for don't know how much. Mix it all together. What type of tea do I want out? $7.50. But how much of this tea do I need? Okay, so make sure we put the 144 underneath. All right, equation number 1 is how much you have and how much you need, right? X plus Y equals 144 pounds. Now apply the money for me. Go ahead, now apply the money. We've applied the percents in the last problem. In this one, we'll apply the money. So who's got my second equation right now? 4. What's my second equation?
6x plus 8x.
8x?
8y.
Yeah, that's what I thought. Equals?
750 times 144.
Good. Please make sure you end up multiplying on the right side. You've been multiplying on the left side. Multiply. So if you want to do 750 times 144 and write in what it is, just make sure you know where it's coming from. What is that number? Somebody will help there.
10.
What do we have?
1080.
1080? All right. Eliminate a variable now. No decimals here. Nice whole numbers. -9, what do you want to multiply by?
-5.
Sure. You could also go -8 if you want to do it that way. Can I get a little help with that number? No, never mind. Oh, yeah, I will need a help.
-854.
8. 54?
Yeah.
54? Yeah.
Oh, it's 64. Sorry.
One job.
Sorry.
Don't
not
do
stuff
that.
today. No, it's from here. No, because
No, I'll be doing it again. I'm gonna start again. Church birthday.
I do know this one. 216. So when you're ready, let me know how much of the $8 T I have. How much of the $8 T here do I have that we're solving for? 9 again when you're ready.
108 pounds.
108. Ooh, that's a lot of T.
Buffalo 8.
Fuck 8. Touche. Clever. 108 lbs. And then how much of the $6 T then when you're ready? 108 pounds, the $8. And then for the $6 T, how much you rolling with? 7.
36.
36 pounds. Yep. Anything I can answer there before I take it to a different problem? Type of problem. All right, mixture. Now we go motion. Motion problems. No buckets here. Plane speed. It can go with the wind. You guys see how far it can go and the timing. And then when it's going against, it takes 5 hours instead of 3. So how fast is the plane going and how fast is the wind going? All right, so I'm going to go variables first because I've been using X and Y. And you guys, I've told you in the past, you can get as creative as you want. I don't care. But since we're doing plane speed, I'm going to go P for plane speed. And it's also asking me the speed of the wind, so that's a W for me. But again, you want to stick with X and Y. Heck, you want to do different variables, go at it. Okay, this is how I'm going to come up with both equations. I don't know if you've ever seen this formula or not. Let me know if you have. When we're talking about motion problems, speed, we're going to use this formula right here. D, distance, D equals rate, R, times time, T. I don't know if you've anybody ever used that in classes? No, dirt. Distance equals rate times time. 2 equations. One going with the wind, one going against the wind. Ready? So let's do with the wind. What's my distance? How far am I going? Okay, ready? 450 equals, and now let me help you out with the rate. Are we going against or with the wind for this one? So I'm going to take the plane speed and add it to the wind speed when I go with it. I'm putting the two together. Plane speed with the wind speed. There's your rate times how long does it take me to go? 3 hours. So I just don't put times 3 at the end. I'm multiplying by 3 by putting those parentheses around and the 3 on the outside. Yep.
Can you explain P plus W?
Okay, that's my rate. So it's going to be plane speed, and then since I'm going with the wind's going in the same direction, pushing me. It's like, you're out for a jog and the wind's at your back and pushing you. So that's why these two rates are being added together. I'm trying to find the rate here, Jared. That's what I'm trying to find. Yeah. So the plane speed or the plane rate and the wind rate are going together. So that's why I'm adding them. Okay?
It says opposite direction. Against the wind.
Well, now I'm going, but this with the wind was 450 in 3 hours. I'm about to write a second equation going against the wind. Ready?
Yeah.
Against the wind, what's my distance? Same. It says same, right? Fly the same distance, 450. But now when I go against the wind, what am I going to do with the plane speed and the wind speed? Well, I know it's going to take, I'm not at the 5 yet. I'm going 4 here because I can't put P plus W because they're not going with each other. Subtract them. So I'm going to go P minus W when they go against each other. And then how long do I have to take? Now that's times 5. Okay, so against, I'm going to subtract. With, I'm going to add them together. Some years I don't do this. All right, I can tell you some years I don't show what I'm about to show because I don't think kids can handle it. But I think I got a strong group this year. Same thing in third period. I got a strong group. So usually, here's what I say, and if you want to do this, you can distribute the 3, right? And you get what? 3P plus 3W. Sorry for all this here. Equals 450. Distribute the 5. You get 5P minus 5W, and then you get rid of a variable like we've been doing. So if you want to keep with that process, that's fine. I'm going to show you a quicker method, though, because I think you can handle it. Can you get rid of the 3 right now for me? How can I get rid of the 3? Go ahead, divide both sides by 3. Watch how easy this becomes now. Divide both sides by 3. You get P plus W equals 150. And then what do I want to divide by in the second equation? 5, yeah, go ahead, divide by 5. You get P minus W equals 90. Everyone's getting 90. You divide by 5. Anybody see why this is going to be a lot easier than maybe doing it up here? Look at these now. Yeah, what happens, Aaron? W's are going to cancel. I don't have to multiply by a darn thing. W's are gone. Here's the only thing I worry about is this next step. What are you left with on the right side? I'm worried now. This is why yeah, not P. How many do you have there? 2P. So, don't just say P equals and then add them together. No, 2P. There's 2 of them there. Equals 240. So the plane's going 120 miles an hour. So there's the plane speed. And then, hey, yeah, find the wind speed now. If you, hey, look, hey, before you go, you can plug it into this one, either any of those you can plug it into. Okay, you can plug 120 in for P. Probably you want to go with one we just created there, right? So the plane's going 120. And how about the wind when you plug it back in? Wind. 4, when you're ready, the wind. 30 miles an hour. Yep. Again, if you want to do my little division right away, go ahead if you can handle it. If not, distribute. And you're going to have to, looks like this one here, you're going to have to multiply by 2 different numbers. So that's a little bit more, takes a little bit longer time. All good? So that's in the air. I can also do these problems in the water now with a current. Okay, a current. Instead of air, now we go on in the water and go against and with the current. Rowing here. All right, what's my rowing speed and what's my current, my velocity or the speed of the current? All right, you set up your variables however you want it. We got to do rowing speed. I'm going to do R. And I'll put C. I'm not going to write current speed because that sounds a little bit different than what we're actually finding, right? But speed of the current, speed of current. All right. If I write current speed, that kind of sounds like how far we're going, how fast we're going now. And always keep in mind, if you forget, anytime we're doing this, the motion problems, distance equals rate times time. All right, ready? Let's go with the current. With the current, what's my distance? 24. All right, just like we were going with the wind in the last problem, now we're going with the current. So I want to take my rowing speed and, yep, add it to the current. How long does that take me?
3 hours.
Times 3. Now you just got to be, you got to read. Sorry, you got to read. Last problem, you were going the same distance both times. Now you're not. When I go against the current, you can only go 2/3 of the distance now. So I don't want to put 24 in to start it off. It's not going the same distance, it's going 2/3 the distance. So what's my D here going against the current? 4 again on fire. 16. And now that'll be not 3, but 4 R minus C. Again, you want to distribute? Distribute. It's going to take you longer, but you'll get there. If you want to divide by 3 and divide by 4, go right ahead. So you get R plus C equals 8. R minus C equals 4. Again, the only thing I'm getting nervous about when you do the division method is making sure you're just not left with R. It's 2R. 2R. Rowing speed is 6. Go ahead, plug it back in. Speed of the current when you're ready. 13. Speed of the current.
6. Oh, T.
T? What's T mean?
Oh, C. 2.
2. Are you good? I didn't know we gave our
I guess
answers
I'm
in
not
letters
good.
now.
No, I finished. So I know what I'm doing.
T miles per hour, everybody.
Just a-
T miles per hour.
embarrassing.
Yes. Okay. Everyone good?
I got
Okay.
it right though.
Tuesday. And hey, this is it. Day 1 and day 3. You know what's on the quiz now. Day 1 and day 3.